In this video, we'll have the demonstration for inserting an element in a sorted array and checking whether an array is already sorted or not, and arranging all positives and negatives on either side of an array. Already we have discussed this topic on whiteboard. Now I will write down functions for them and I will show you. So I am using the same program which we have already used in the previous topics. So all those functions are present in the same project now, same program file. And here I have an array which is initialized with some number, and these numbers are already sorted. Now let us write a function for inserting an element in a sorted position. I will call the function name as insert sort, and it should take a array as a parameter, and it should be by reference. And next is the value that we want to insert. So for inserting an element x in a sorted position, I should start shifting the larger elements from the right hand side of an array and make a free space for x and insert it. So I will write on the code what we have already seen on whiteboard. So before insertion, first of all, I should check whether there is any free space in an array or not. So if array's length is equal to array's size, then there is no free space. So I should stop the function. So I will simply say return. Means if length is equal to size, then there is no free space. Otherwise, I can insert. So for insertion, I have to shift the element. So for that, I need a variable I, and that should be initialized with arrays length -1. Then as we have already seen that I have to go on shifting the element, so I should do it as long as while a of I is greater than x. If so, then I should shift an element at a of I plus 1. I should write down the value from a of I. And I should decrement I. And one more thing I should take care that I should not cross 0th index. So one more condition, I should be greater than or equal to 0, as well as this condition should be satisfied. If I am inserting a smallest element, then it should come at index 0. Beyond that, and below index 0, there is no valid index. So I should stop when it has reached 0, right? So if it is becoming -1, it should stop. Then after coming out of the loop at a of I plus 1, I should store the element. As we have inserted one more element, so the length of array should also be incremented. So length plus plus. So that's all. The function is ready, which can insert an element in a sorted position. So let us try it in main function. In main function already I have an array. The largest element is 15. Now let us insert an element by calling this function insert sort, and it takes address of array object, and the value that I want to insert is 20. So let us first insert 20. 20 should be inserted at the end of this array, that is after 15, because this will be a greatest number. So display should display all the values along with 20. So this display function will display all the elements. Yes. Now it is displaying 6 elements including 20. Let us change the value. I will try to insert something between 10 and 15. So I'll give the element as 12. So it should be inserted after 10. Let us see whether it works. Yes. 2, 3, 5, 10, 12 and 15. It is inserted in a sorted position. If I give the value as 4, so it should be inserted in between 3 and 5. Yes, 2, 3, 4, 5, 10, 15. If I give a value as 1, then it should be inserted before 2 because it's the smallest element. Yes, 1, 2, 3, 5, 10 and 15. It is inserted. So that's all with the insert function, inserting in a sorted array. Next, I will write a function to check if an array is sorted or not, that is sorted. So return type is integer. It will return whether array is sorted or not. So it will return true or false. So true means it will return 1, otherwise it will return 0. Is sorted. So it should take an array. So struct array arr It should take the value by value. We don't need by address because just it has to check. It doesn't have to modify an array. Then to avoid an error here, I will write return 0. Otherwise, the compiler will show error here. As we have already seen the procedure on whiteboard, so we need to use for loop for scanning through this array. So for that, I will take I. Then for loop, I starts from 0. I should be less than array's length minus 1 because we should stop one element before as we are comparing two elements. So every time check what if a of I, if a of I is greater than a of I plus 1, then it means they are not sorted. Any two elements are such that first one is greater than the second one, then they are not sorted. So we will return false. False means 0. Otherwise, when we come out of this for loop, we will return 1. Means if return 0 was not done, we have checked the complete array and there was no such condition, that is the first element was greater than the second element. So array is already sorted. So this discussion already we have done. Now I will use that function. I will call that function here. So I will directly print the value. Printf percentile d slash n is sorted. I will pass an array. So I'm passing this array to this function to check whether it is sorted or not. We can see that this array is already sorted, so it should return 1. So printf should print the value 1. Yes, it is printing 1. I will modify this array and make it unsorted, so I will write 25 here. So 2, 3, 25, then 10, so it is not sorted. See one of the element that is greater than the next element. Let us run and see what's the output. See, output is 0, means it says that array is not sorted. Yes, correct. So it is returning true or false. So wherever you need it, you can use it to check whether it is sorted or not sorted. Call this function. It will help you in taking decision by sending true or false, that is 0 or 1. Now the next function remaining is rearranging positive and negatives. So for that, I will write a function rearrange, and it should take a struct type array and it's going to modify an array, so it should be called by address. I'm calling the function name as rearrange. As we have already seen the procedure, so I will declare the variables I and j that we need. I should start from index 0 and j should start from index arrays length minus 1. That is the index of last element. Then using while loop, we have to iterate as long as I is less than j. Then each time increment I, so I will use do while loop here. Each time increment I as well as a decrement j, so I will use while a of I is less than 0, means if it is negative, then increment I. And same way, I should decrement j if a of I is greater than equal to 0, j minus minus. So this procedure already I have shown you, so I'm not explaining it here. If I is less than j, then swap. So already we have a function for swap. So I will call that function swap by sending addresses of AR of A of I and array of A of j. These two elements we will interchange. So that's all. So if I have some positive and negative elements scattered in an array, then it will arrange all negatives on the left hand side and positive on the right hand side. So I will try to write some negative numbers also. Here is minus 15 and this is minus 3. So then I will add one more number here, minus 7. So this minus 3, minus 15 and minus 7 should be on the left hand side. So let us call this function. I will remove this. Rearrange, send the address of array. Now total elements are 6, so I should modify this length also to 6. Now let us run the program and see what happens. Yes, all negatives are on one side and positive are on the right hand side. So you can see that 2 is swapped with -7. Then 25 is swapped with -15. So 25 went in a place of 15. So that's it. This is working. We have seen three different functions, that is inserting an element in a sorted position and checking whether an array is sorted or not, or rearranging the elements.